Hello students, last class we did some questions about the quadratic equations. If you haven't watched the videos, you can go back and watch or I'll link the videos in the I button. Today's class we will learn how we can use a shortcut to find the nature of the roots, whether the roots are real, they're equal, they're unequal or complex. So to do that we'll have to do this. The standard form is what? Ax square plus bx plus c equals to 0. A is not equals to 0. And this is how we find the roots minus b plus minus root over b square minus 4ac by 2a. We already learned that in the last question. ABC belongs to real numbers. So what we're going to do is we'll find the value of the part which we write inside the square root. That is, we'll denote it as delta, which is equals to b square minus 4ac. So whatever value we get for this value, that we can easily find out whether the roots will be equal, unequal or complex. Okay, so there are the standard rules given over here. Let's look here. So first condition is case 1, when a, b and c are real numbers, okay, and a is not equals to 0. In that condition, if we get delta equals to 0, if the delta value comes to be 0, that means inside the root you get 0. The roots are equal and real. Suppose one root you got 1 by 4, then both roots will be 1 by 4 and 1 by 4. Second condition says if the value is becoming more than 0, suppose it's becoming 23, then the roots will be real and unequal. Okay. Third condition says if the value of the delta is less than 0, suppose we got something like minus 32, then the roots will be complex. Like how can we write root over minus 32? It can be written as 32i. So we will get roots in this notation, that is root over 32i, and those we can get a pair of complex conjugates. What does that mean is, suppose we got the roots as 2 plus minus root over 3i. This means what? One of the root will be root over 2 plus root 3i, another will be 2 minus root over 3i. These two are called complex conjugates. Easy. Now let's look at the case 2. The case 2 says if a, b, c are rational numbers and a is not equals to 0, and in that case if we get the delta as equals to 0, the roots will be rational and equal, quite similar to the previous one. If delta is greater than 0, now two things we'll have to see here. If the delta is greater than 0 and a, b, c are rational numbers, if the delta is a perfect square, suppose we got like root over 64, in that case what will happen? The roots will be rational and unequal. Okay, same delta greater than 0, but we got something like root over 63. Here what's happening? The delta is not a perfect square. Now these roots will be irrational and unequal. Easy. So this root will be irrational and unequal roots. Last, if the delta is less than 0, similarly we're going to get a pair of complex conjugates, just like in the previous one we saw 2 plus root 3i, 2 minus root over 3i. So these are certain conditions depending on which we're going to find out about the nature of quadratic roots. Let's try some questions over here. So here we have discussed the nature of the root. So you'll get questions like this. They will give you a quadratic equation. They will ask you to find out the nature of the root. So we'll follow the conditions over here. So let's start the first question. So it's given 3x square minus 10x plus 3 equals to 0. So what I can do, I can write a is 3 over here, b is minus 10 and c is 3. What do we need to find? We'll just need to see the value of delta, which is equals to b square minus 4ac. Let's put the values over here. It will be minus 10 square minus 4. A will be 3 over here and C is again 3. So what will be the value? Minus 10 square is 100. 3 3 is a 9. 9 3 is a 9 4 is a 36. So the value is coming 64. Now what we just learned, these ABC are rational numbers and we're getting delta as 64. Now we all know that 64 is a perfect square. So what we saw over here in case 2 of part 2, when delta is a perfect square of a rational numbers, then the roots are rational and unequal. So what are we going to write over here about the nature of this quadratic equation? We will get roots which are rational and unequal, right? That's what we saw here. Yes, rational and unequal. I hope all of you understood how I did this question. Let's try one more question. In this question, let's write the equation. We have x square plus x plus 1 equals to 0. A we have 1, B we have 1, C is also 1. Let's find delta. Delta is what? B square minus 4AC. So B is 1 square, here 4 into 1 into 1. So it's 1 minus 4, we're getting minus 3. So here all the coefficients are rational 1, 1, 1. Now see the delta value is coming less than 0. So when it's less than 0, what will be the nature of the roots? So we will see here. Then the roots are a pair of complex conjugates. So we can conclude that for this equation we will get roots which will be a pair of complex conjugates like a plus root over bi, a minus root over bi, something of that sort. Easy. Let's try another question. Quite similar here. A, what do we have? Root 2 root 3. B is equals to minus 5. C is equals to root over 3. Now, see, A, B, C are not rational numbers, okay? Because there's a root over here. So let's find the delta first. It will be B square minus 4AC. So we have minus 5 whole square minus 4 into 2 root over 3 into root over 3. Minus 5 square is 25. Here root 3 into root 3 will give me 3. 3 into 2 is 6. 6 fours are 24. 25 minus 24, it's 1, which is greater than 0. So here what we got, the coefficients are real and the value of discriminant is greater than 0. So we will go and see the first one. Here A, B, C are real numbers and delta is greater than 0. So the roots will be what? The roots will be real and unequal. Easy. So in this case, I'm going to say the roots are real and unequal. I hope all of you understood. Let's try a different question. Okay, let's try the last question we have. So here it's given a, b, and h belongs to real numbers. Show that the equation has real roots. So we have the equation as x minus a into x minus b, which is equals to h square. So if you break it down, what are we gonna get? We will get x square minus a plus b into x plus ab equals to h square. If we further simplify it, we will get x square minus a plus b into x plus ab minus h square equals to 0. Now see, it looks like a quadratic equation. What do we have in place of a? We have 1. In place of b, we have minus a plus b. And in place of c, we have ab minus h square. Now, if we find the discriminant, that is delta, so delta will be equal to what? Delta is b square minus 4ac. So in place of b, we have minus a plus b whole square minus 4. A is 1, c is ab minus h square. Let's solve this. So this minus and square, it will become plus a plus b whole square will be a square plus b square plus 2ab. Here if we break it down, we're gonna get minus 4ab plus 4h square. 2ab minus 4ab, we will get a square plus b square minus 2ab plus a square. This part will be what? It will be simply a plus b whole square plus h square. Now see, in the equation it's given a, b and h belongs to real numbers. No matter what real numbers you put in place of a and b, since it's a square, even if it's a negative value, we will always get a positive number out of it. Similarly, one second, it should have been 4h square, yeah. So 4h square, in place of h also, no matter what value you put, you will always get a positive number. So what we can conclude from here, from this value, we will always get something which will be greater than 0, or there are possibility that this can be equal to 0. So hence it is proof that this equation has real roots. So I hope all of you understood these 4 questions. If you have any doubts regarding this, you can ask me in the comments. I will see you students in the next class.